Hi guys, I'm working on getting Home Assistant up and running in my house. In that process I decided to make this ESP32-S3 demo board in order to make some of my own temperature and humidity sensors. This is just the initial prototype, the final ones will be even smaller and they will be battery operated. In this video we'll go through the whole process from making and designing the schematic to routing and ordering the PCB. The main features for this board are an ESP32-S3 Wi-Fi module with 8MB flash, an SI7021 high precision temperature and humidity sensor, a quick connector, a USB-C connector for power and programming, buttons for boot and reset, a user button, a user RGB LED, a 10-pin SPI bus expansion header, a 6-pin programming header, power LED on the 3.3 volt rail, and for the mechanical side of things then we will have 4 3.2mm mounting holes, and the size of the board should be 50 by 50mm, and I would like it to be a 4-layer board design. Just before we start the project I would like to thank PCBWay for making this video possible. Remember that there are a large section on PCBWay.com where you can find a lot of projects and inspiration from other makers. If you find a particular project interesting, then you can often directly order the PCB at PCBWay. You find my affiliate link in the video description of this video. Please use it and thereby support the channel. So remember to visit PCBWay.com. So let's dig into it. So here we are in KiCad 9, and as you see I already named the project ESP32-S3 Testboard. And let's jump into the schematic design here. And here we have the standard size schematic, and let's enter some details about the schematic itself. So we go into page settings and we see this is an A4 size and the landscape format. I think that's fine for this project. Let's insert the date. Revision, that's 1.0. Title, ESP32-S3 Testboard. And company, that's made by Morten. And I think that's good for now. And as you see, this has been entered down here already. I have a spelling error here. Like that. So the main thing we have to put on here is of course the processor. So we go to place symbols and let's search for the ESP32. Just have a few libraries that has to be loaded first. Like that. See if we can find an ESP32-S3. And I think I have one here. Like that. And some of the other building blocks is the temperature and humidity sensor, that's SI7021. And let's put that down here somewhere. And of course we have the USB-C connector. So we go to place symbols. And we will look for a USB-C connector. I think I have this one here. Let's place that here. And what we need is also the something that can take transients off. So let's see if we can find some protection device for it. So there's some ESD protection device here as well. What we need is also a programmer interface for the ESP32. Normally I use an 2x3 pin connector for that. that's compatible with the ESP proc from Espressif. And that's just a pin connector. And we can just go down and find it in connectors here. And it's generic, and it's 2x3. Odd even. We also have the symbol over here. Let me just arrange it so that it's easier to see. Like that. I think that's good. And let's place that over here around the ESP32. And we also need a 2x5 when we are in here for the SPI interface. And this should be this one. And we also need a power supply, so we can put on a 5 volt to 3.3 volt converter, and I just need a standard LDO for that. So typically that's LM11 17, and this is the 3.3 volt one. And we also need an RGB LED. Let's see what pops up here. Maybe I have one in my custom libraries. Here we go. And I would also like a small LED indicating that we have 3.3 volts on. So let's see if we can find that one as well. So we have this LED small. We can put it here near the LDO. And I would also like to have the quick connector, and that's where 1x4 pin connector. So we can just see if we can find that. I need to clear the search bar here. And I have one down here, hopefully, like that. And we need a couple of buttons as well. And we have some buttons here, I hope. This one. And we need 3 in total. So see if we can copy that one, duplicate that. Like that. And of course we need some mounting holes. We can just put them down here. And we need 4 of those. Like that. Okay, let's focus here on the first block, the USB-C interface. And we have VBus up here. So what I would like to have on this demo board is just a small fuse, then a diode, and a ferrite bed as well. So let's place those guys. So I have the poly fuse here. That should just be like a 1 amp fuse. And place the ferrite bed. And then the diode for protection of the polarity. Let's see if we can find that one. We have a small SMD diode here. Like that. And if we connect all that together, delete wire, and then we will come in here to a 5-volt rail, and we can put some power label on it, power symbol, and that will be like 5 volts. That, and I would like to move that a bit closer here, like that. And then we can move around on the text a bit. Like that. And for this one, I like the BLM21 PG220. That's a standard one that I have in my drawers. And move. Just put that a bit further away. Like that. And then we have the fuse here. And we can just write polyfuse 1 amp. Like that. And then we have the signals here. So CC1 and CC2, that's for the current limiting factor on the USB-C interface. So these should just be connected to 5.1 kilo ohms resistors. So we will just make a few wires here. And that's the same goes for the D plus and D minus signals here. And we should tie these ones together. And then delete that small one now. And we will just label those. That's just press L, CC1. And then this guy, CC2. And down here we have D plus and D minus. D minus. Like that. And then we can move away the transient protection a bit. And we would like to have the company or the part number down here and the designator here. So this pin, the supply pin here, should be connected to 5 volts. So we can just grab it up here, control duplicate. And then we need a bypass capacitor as well here. Wire. Something like this. And then we need a capacitor. I have this one C small. And we should name that 100 nano. Like that. later on I will change the footprints for all the parts. That's easier to do in one go in another menu here. Let's just focus on the design of the schematic first, and then we will do the footprints later. And then we need to place a ground symbol like that, and just a wire. And I would like to have that a bit closer as well, like that. And we of course need that on the capacitor. Like that. And then maybe we should move this up a bit. Something similar to this. I think that's fine. Great, and now we can connect the D plus and D minus to the transient protection. We can just copy the signals here, along with the wire, duplicate. Like that. So now we have the signals on the input side, and of course we need them on the output side as well. And just, we of course have to rename them here on the other side. So we will just call this USB D plus and USB D minus. Yep. So let's take care of the two 5.1 kilo ohm resistors that needs to be connected to these two. And let's find a symbol for the resistor. I have this R small, like that, and the value, the value for this one, 5.1 kilo. And we can move this down here, move the designator down here a bit. Like that. And then we can move them a bit apart. R1 and R2. And let's connect those two pins to ground. Like that. And then we duplicate the ground symbol like this. And the remaining signals here, they are no connect, and the shield and the ground, we just tie those together and place a ground symbol here. Like that. And then we can say no connect to these two signals. Place no connect flags, like that. So now we have the first block here. The USB-C interface is complete, and we can just take those two signals here, and we need to connect those to the ESP32 over here. Then we don't forget that. Like that. Like that. Now we have the USB system is okay, and we can move on to the LDO down here, and then we will take the 5 volt we have here from the USB port and feed that into the LDO. And we do it like this. And we of course also need some decoupling capacitors on this one. So we can just grab it from up here. And that should be like a 22 microfarad capacitor. U. And we also need a ground symbol on the middle pin. And the output, it's just similar to this. Then we have the same distance here. And we need to place the power label, and that's 3 volt 3. And again we need to move that a bit closer here. Is that on the same level? Should be moved up a bit. Like that. Let's move it a bit closer here. G. Two points in. And this should also be a bit closer. Like that. So let's put a resistor in front of this LED as well. So this should just indicate that we have power on the board. Place symbol small, and we will do it from 3.3 volts. And we just tie everything together. And we call this a 1 kilo ohm resistor is fine. And D2, that should be like a green LED. Just see what happens if we draw this a bit closer. Yeah. Then we have everything on the same height. That looks good. All right. Now we have power to the system. And I would like this RGB LED, a programmable RGB LED, RGB here. And we just need to power that from 3.3 volts. I would like to just rotate it a bit. Like that. And we just connect it to 3.3 volts. And we have 3.3 volts up here. Just move this down a bit. And then we can copy some of the 5.1 kilo ohm resistor here. And we just need to rename them. I'll always use 1 kilo ohm resistors here. And maybe we can have that label down here. Let's try and duplicate that. How does it look? There's not room enough. Let's just move it up here. And then we can duplicate all this. Like this. And then we need a port pin that can control this. Maybe we need a bit larger. So let's name that. So press L, and we will call the first one R for red LED. And then we have G LED. And then we have the blue LED. B LED. Like that. And again, let's copy these signals so they have the exact same names and put them over here. Then we can connect them to the ESP a bit later. So power, USB, the power, the RGB LED, and then we have the quick connector. This is a connector for connecting different I2C interfaces to the board. This is a quite popular interface. And we just need to transform this to that. So we need I2C, and you can also find the connector pin out at the Sparkfun's homepage. There's also a description about the whole quick connector community there. But pin 4, that's SCL. I think this is fine. Wire. And pin 3 is SDA. Then we have pin 2 that's connected to 3.3 volts. And we have 3.3 volts flag here. And then we have ground on pin number 1. So we just need to grab ground symbol there, duplicate, and we place it around here. Like so. And of course on the I2C bus we need some pull-up resistors. And we can grab that one here. Oh, sorry. Copy that. Duplicate. And let's place it around here. I think that's okay. We can move it out a bit. And that should be like a 2.2 kilo ohm. And we need one more for the other line. Just remove that one. Like that. And we can move this down a bit so that it is in the same level. That's simply just press G and then move the wire you need. And let's extend those a bit so we can put some labels on. And there we have the first line and the second line. And pin number 4, that was SCL. So let's place a label for that, SCL. And we have SDA on the other one. Like so. And again, let's copy those signals and put them over here near the processor. And we can also put a small text box on here. Place and then draw texts. I think that's fine. So we can just put a bit about the colors for the signals, the signal wires that are on the QWIIC connector. So we have the ground wire, and that is a black wire. And we have the VCC, and that is a red one. And we can just say equal black here. And we have SDA. That's a blue wire. And we have SCL. That is a yellow wire. Like that. And we can just make the margin a bit nicer. Like that. All right. We can move this up a bit. And I think we will make some small boxes to put all these small blocks inside, so it's easier to read the schematic. Down here I would like to route the humidity and the temperature and humidity sensor. And we need to connect the SDA and SCL lines. This is also on I2C. And we can move it a bit closer. And G. Like this. And we should also put some power to it, and we again take the plus 3.3 volt. And we need a 100 nano decoupling capacitor. We can take this circuit up here. And maybe we can go out this far. That. Something like that. And we need to connect ground to the ground pin. And we see there's an extra pad here. I can't remember if we should connect that one to ground. Let's check it up. And let's check if there are some description of it down here. I think normally they have that in the top of the document. So this is the do not connect pad. I just need to check up what we should do about that one. That's strange. Normally you write that in the top of the document, but here it is. So do not connect on pin number 3 and 4. So I just leave that unconnected. And I just need to verify that one more time. So this is the pad. This is a ground pad. That's pin number 7. So this is just not connected. So we will place a non-connect. Like that. So that should also do it for the temperature and humidity sensor. Then we have, move this down a bit here. Then we have the SPI port interface. And this is for, you know, a later project where I will do a Ethernet shield and the feautures Ethernet chip will be connected to the SPI port. So I would like to have ground and power connected to it. I'll just rename this one to pin 2x5, like that. And let's connect 3.3 volts. That. And like that. And I will put some ground. And we can grab it from here. like so. And then we need to insert some names for the SPI port. So we have 6 signals. So normally on a SPI port we have signals, MOSI, and we have MISO, and we have chip selects, and we have the clock, and of course we would like to have an interrupt as well. ERQ, and finally a reset signal as well. And of course we will copy these signals to the MCU part. As well. Alright, then we will have some switches. I know that we'll need a boot switch and a reset switch and then a user programmable one. Can just move them around a bit here. I know we need one close here to the enable signal that's equal to the reset pin. So let's wire this up, and afterwards we can make some blocks here to define the different functions here and put some labels on the different blocks. But let's wire the reset switch. And normally there's a resistor, a pull-up resistor and a capacitor to delay the reset pulse a bit. So let's put 3.3 volt and a pull-up resistor here. And this is normally 10 kilo ohm. And then we have a capacitor. Grab it from here. And that should be like 10 micro. Oh, sorry, 1 micro. And of course I need to move the switch here on here. And I would like to have some ESD protection here on the reset pin, because you have your finger here. Place symbol, and I have a small ESD diode here. And I will just rename it, sorry, ESD 3.3. Like that. And connect that to ground. Then we have our switch here. And of course this is then going to ground. Yep. Perfect. And now we're here, we can also connect ground and power to the MCU or the ESP32. Just have ground on these wires. And then we have the 3.3 volt power. And we need some decoupling capacitors as well, close to the pin. And let's take a couple of these. And make this 10 micro. And the one closer should be like 100 nano. Like that. Yeah. Now we have the reset switch here. We can just call that reset. And then we have the boot switch, and then we will down here we will have the user switch. Let's call that user switch like that, a button. There's one thing that we need to take care of, and that's there are some pins here that are not so good to connect anything to. I have a small list here that we can grab and just put that text into the schematic. And then we can place a text box. And then put the text in. And maybe we need to rearrange it a bit here. Like that. I think we need to make it a bit larger. Something like that. And we can move it down a bit. So we have to take care of not using GPIO 0, that's the boot pin, and GPIO 45 and 46. We should also keep away from those. And also, if you use other types of the ESP32-S3, with embedded memory, then you should take care of using IO35, IO36 and IO37. And as you see, I marked them here with a small star over here, that you should take care of not using those. And also keep in mind that GPIO 45 and 46, they can also be problematic to use. And of course, please dedicate GPIO 43 and 44 for the programming pins or communication on the UART. There's also a document, I found that here on Espressif's homepage. There's also a link to it in the video description. There is a description here of all the pins and which strapping pins you should avoid. This is quite good. And there's also later on when we need to define the H2C pins and the SPI pins, there's also some default pins here if you are using the Arduino framework. And of course we will try to make it compatible with that. So let's get started routing the last things here. So we know from the text here that GPIO is floating by default, so we need to wire it to VCC through a pull-up resistor, else we could see some unexpected boot behavior where it will go into boot mode instead of just running the application. So we need to place a small pull-up resistor here, and that should just be like a 10 kilo ohm resistor, pull-up resistor. So we can grab this from here. So like that. And GPIO 0 should be connected to the boot switch. And let's put a label here on this, ESP32-IO 0. Like that. And then we need to connect that to the boot switch over here. Like that. And of course we would like to have a transformer, not a transformer, but a transient protection circuit. Like that, and this should just pull it to ground. That's just move this up a bit. And then we have them on the same level as well. So I think we can move the whole MCU part here a bit. Let's move it over here. Then we can group all these smaller things a bit prettier. Like that. And maybe we can move this up a bit. So we have equal spacing in between the different functions here. I think that looks fine. So we could place some lines, draw lines, and let's try and see if it's something like this. And then we go from here to the bottom. Like that. And then we can go through here. That's place line or draw line. Like that, and then we can go across here. So, and then we can duplicate this one. Approximately around here. And then we can of course twiddle a bit the things here, just to get it centered. that. Should be up one notch higher. And then of course we can make a small label on each box just to make it clear what it is. Draw some texts. And we should call the first one up here USB-C. And we would like it to be 100. Yeah, something like this. And let's move on and call this LDO. And we have RGB LED. And down here we have the quick connector interface. And here we have the sensor. Temperature and humidity sensor. And I'll just call this one I/O. These signals can of course be used for other things as well. They are not dedicated to SPI, but that's what I'm going to use them for in my next projects. And then we have the boot switch here. Like that. Okay. Just close this one a bit. I think that looks fine. We just need one more up here to indicate that this is the ESP32-S3 module. Then we move that in place. Like so. And then we can just move that a bit further up and to the left. Then we have a bit of room for the last few things. We have the program connector and we have the user switch to take care of. So we can just grab some of the same functionality that we have up here. And bring it down here. So the switch should connect to ground. And we have the pull-up resistor and the ESD diode. I'll just bring that closer to the switch here. RG. Then move this switch like that. And then we have them on the same line. And we can make it a bit shorter, this one. And we will put a label on here, user switch. Like that, and then we can copy that one as well up here. Yeah, I think that's location is fine here. So the programming header here for the MCU or the ESP32, it has normally 3.3 volt here. And you can either program the MCU from the USB port or from this programming header here. And then we have ground here on pin number 4. Like that. And then pin number 6. That's connected up to this pin here. So we'll just copy the label. ESP32-IO0. And then we have 3 more wires over here. And we have the reset pulse up from here. We'll just put a label here on the enable pin, label ESP enable, like that. Then we can duplicate it and put it down here on pin number 1. And lastly, we need to connect TXD and RXD. So let's put labels on here, ESP TXD. And one more label, ESP RXD. Like that. And we need those 2 as well on the MCU. These are easy to put on. Because they are already labeled here. And should we have them in the same length? Try and do that. So this is the length up there. Like that. And we have TXD here on the first one and RXD on that one. Delete. I think that's fine. So now we need to put the remaining labels on here, or connect the remaining signals to the MCU. We can just give that one because I made a mistake here. That should be, of course, GPIO number 3. like that. And we have the length defined here. So I would like to have the LEDs here on GPIO number 39. Move them away. Like that. Like that. The red LED, green LED, and the blue LED. Like so. And we should also have the USB signals in the same. See if it's possible, just remove those. Like that. Like that. And the user switch, we can put that down here in the bottom. On GPIO 48. And let's take the label. Like that. So we have the SDA lines, the I2C port, and we have the reset pins, or sorry, the SPI pins, and the reset signal, and the interrupt signal as well. So in order to be Arduino compatible out of the box, let's check out what we should connect SDA and SCL. So we say SDA should be GPIO 8 and SCL should be 9. So 8 to SDA. SDA there. And move SCL like that. And for the SPI port, let's check out which signals we should use there. So chip select on 10, MISI on 13, MOSI on 11, and clock on 12. So chip select and MOSI. So that was 10. So chip select, I believe that was 10. And MOSI on 11. 10 and MOSI on 11, then 12 should be clock. Just need to move those a bit in here. This looks a bit better if they are online. Like that. And MISI on 13. And then we have the interrupt signal. It could be here on 15, and then the reset signal could be here on the number 14. Like so. And I don't think that we have other signals that are going to be used. So we have ESP IO0. We have the pull up on GPIO 3. We have SGA, the I2C pins on 8 and 9, the SPI port on these 4, support signals on these 2, USB. Then we have the RGB LEDs. Then we have the programming pins, the UART, and the user switch. I think that's it. Let's connect some not connected flags to the remaining pins. And of course, if you want to make your own board, feel free to, break all these signals that are not used out to some different connectors. Like that. Like that. We're quite lucky we could have everything here on one A4 schematic. Or else it's just select, the next size is A3 if you need more things. But I think this makes it very clear by dividing everything into smaller blocks. Gives a quite nice overview of what you're designing. Maybe this should just be down one notch like that. And this one down a notch. Yeah, you can use a lot of time, moving things around, but for now I think this is good for the schematic design. What we have to do now is to select the footprints. You select the footprints before you go into the PCB layout, and all changes for footprints and so on are done here from the schematic. And what I find the most useful is to change them in one go. You can of course always just double click on one part here and then select the footprint, but I think it's very tedious. Normally I do it here, go to tools and then edit simple fields. And I just need to move it about. It's on the other monitor right now. See if we can make it a bit smaller, the window, like that. And like that. And you can see all the details here. There's links to different data sheets and the footprint, and if you should not populate every part, then you can remove that from the bill of materials. But let's see, to make it a bit more easy to digest, we can remove the data sheet, for example, like that. And then we have the footprints over here, and we have the part numbers and the values here. So let's see if we can maximize this one. Yep. So let's start from an end. We have the 100 nano, and I would like to use 0402 for the smaller capacitors and also for the resistors. So we see capacitors, and we find SMD capacitors, and we need some 0402, and I like the hand solder version for the smaller things. And for the 22 microfarad capacitors, I would like to have a 0.8 footprint. I can do that with those, and this should be like an 0.603. And then we have the 10 micro, that could also be an 0.603 for now. Then we have the RGB LED, that's already defined. Then we have the green LED. Let's find a footprint for the LED. LED SMD, and I would like a 0.603 in size, that one. And the ESD protection diodes is already defined, and I would like a 1206 for the fuse. Let's see if we can find the fuse here. 1206, 1206, and this is an 0805 inductor. L0805, and the mounting holes I think they're on the mounting hole here, and that should just be a 3.2 millimeter standard mounting hole. Yeah, let's take this one. Then we have the USB-C connector. Connector USB we have here. There's a lot of different ones to choose from. Just go down and see the footprint if we have something that could be interesting. I would like a pure SMD one. And I need a 12 pin. I think this one looks acceptable. Let's take this one for now. And then we need some standard pin headers. And let's try and find them down here. 2x5. This one. And the next one is this was the 2x3 one. And the next one is 2x5. That. Then we have the quick connector. And that was a JST connector. See if I can recall the footprint number. JST connector JST. I think it was SH series. SH, something similar to this one, but I think this is the vertical. I need the horizontal version of this one. This is this one. And for the resistors, I just need some 0402 ones. So let's go to resistors. SMD. And the hand soldered version of the 0402 one. This one. And then we can just copy the footprints down here, down the line. And for the switches, let's see what we have there. Maybe it's called buttons, switch SMD. And we can just have a look here. What could be nice? Let's take this one for the boot and reset. Like that. And then for the user switch, I would like one where there's a press from the side. And that's not SMD, that's actually a through-hole one. And I cannot recall the exact part number, but then it's nice that you can look at the footprint here on the right side. And it could be nice if you could also see the 3D model. I think it's something like this one. Yeah. Like that. And we have the transient protection that's already selected. And then we just need to find the footprint for the LDO. Like so. And that's in package SMD. And that's SOT 223. Like that. So now we have selected footprints for all the parts. Then we can say apply, save, schematic, and continue. All right. Save. And let's do a annotation of the whole schematic, and annotate schematic and entire schematic, and just reset everything, and then just do it in this pattern. We can just do it by this way, and then annotate, and now everything is sorted. So we start with the lower numbers here, then go right, and then down here, and then over here. So R8 and C7 are some of the larger values. Maybe they're a bit larger down here, C8. So we are ready to import all the parts into the PCB layout, and let's take a coffee break, and then let's continue on routing the PCB. Yeah, welcome back. Just before we start the PCB layout, I can just show you some of the things you can do. It could be very nice to generate maybe a bill of material. So that's also something that you can do from in here. So go down here to go in Tools and then Generate Bill of Materials. And here you have a CSV file, and you can select different formats out here and then export the file. And of course you can also print the schematic if you want it out on paper. So you just say print, and you can get it in color if you want, if you have a color printer. And just select print preview to see if everything is okay as you expect. So yeah, quite handy. But let's get started with the layout, and you just go up here into Tools, and then you say Update PCB from Schematic. And then it will load the necessary footprints, and it will give you some warnings if there are some. And we see there are no warnings or no problems. We just say Update PCB. And we see here that finally there's 2 warnings that there are some unconnected pads on the quick connector, and that's fine. So nothing serious. And we close this one, and here we have all the parts. So you see they are just placed in a huge mess. So let's define a PCB and then drag some of the most important parts to where we want it. So you see here that the grid size is 0.1 millimeter. I normally make the outline with a 1 millimeter grid. And let's take and place the edge cuts. This is this layer. And then we say place a rectangle. And we want it to be 50 by 50 millimeters. That's it, like that. And then you can go and round the corners a bit, shape modification, and then fillet lines. And I would like the radius to be 4 millimeters. Like that. That's quite easy to make rounded corners like that. And then of course we can drag the mounting holes in here. And let's try and put them in the corners. Like that. And the next thing we want to do is to put some dimension on it. So we go to the user 1 layer and place draw dimensions, and we can put one here on each side, like that. So this is 50 millimeters. And this is also 50 millimeters. And we would like to have the center here as well. And we want that to be 25 millimeters. Like that. And we can do that. Oh, that should be fine. Like that. And then, of course, the module is the most important thing. So let's try and put that in the middle here. And we want the antenna to be outside of the board. And maybe we should change the grid now to a smaller one, 0.1 millimeter. And then it's easier to get located here in the middle. I think this should do it. Then we have the antenna out in free space. The other thing I would like to have as soon as possible is the USB connector. And I want it to be just a bit outside of the enclosure, or if I need an enclosure around it, I would like to have it a bit outside here. Something like that. And it's placed in the middle now. Then we have the quick connector. Let's try and put it over here. Like so. And then we have the SPI connector. Something like over here. Maybe that there. Then we have the LDO. Let's put some of the larger parts in place. Something around here. And then we have the programming connector. Can put it up here, close to some of the signals up here. Yeah, something like that. Then we have the user switch button. I'd like that to be up here somewhere. That. And then we have the two smaller buttons, the reset button and the boot button. And we could place them like this. So close to the edge. And then we would like to have the ground close to the edge, like that. And then we can just switch this to the silk screen. Then we have it. Sorry. And this is also silk screen. Then we have a label on the buttons as well. Could just maybe make it a bit thicker. I think I'll keep that 0.15. What else do we have? We have the protection circuitry. Let's place that close to the USB connector here. Like that. have the RGB LED. Can put it over here somewhere. That. Then we have some of the circuitry for the power supply. Let's move those two here. Let's check out if we have some more parts. We have the inductor, and they should be over here in this area. Okay, I need to zoom in on that. Move. Something like this. And we can turn on off some of these, maybe the fabrication layer, we should turn that off. It makes it a bit easier to see what we're doing. And let's get these smaller parts a bit closer. This is just like a rough thing that we're doing now. You can always fine tune. And here we have the humidity sensor and temperature sensor. We can place it up here. Like that. Then we have two capacitors. I believe those are the ones for decoupling the LDO. You can have them down here. Like so. Then we have the smaller parts for all the switches. Let's place them close to the switches. Like that. D2. Let's move D4 here. That. D6. Like that. And of course, when we, when we select a part here, that becomes visible in the schematic. So we can just have a look on the schematic. So you see we just highlighted R7 and the other way around. Then we can easily find all the parts. So if I, here in the schematic, if I want to find these three LEDs, I highlight them here, then go to the PCB, and then I can just say move, and then I can move these three parts that are connected to the LED. And let's place them roughly. So it makes sense. And the last one up here. Like that. And then we have the LED for the power. And I think we have a bit of room over here. And there's also a resistor connected to that. So let's look in the schematic. Need to highlight the D5. And there's this resistor here, and that's connected there. Something like this. So we have some bypass capacitors for the MCU. So this is C2 and C3. They're here. And they fit up here. And we will need the larger one to be on the outside. And the smaller one to be closer. Like that. And can just have a look in the schematic. So the parts needed for the reset switch is R1 and C4. And we can place them closer here to the reset switch. Like that. And what else? So we have the small pull-up resistor here for GPO3, so that's R1. And we can place it up. Where do we have that point? It's in there somewhere. Let's place it up here for now. Then we have the pull-up resistors for the I2C port. R10 and R11. And let's smooth them up, get them up here close to the connector. Then we have a decoupling capacitor here for the temperature and humidity sensor, R8, or C8, sorry. And we need that to be close to the power pin. There. So we have these parts, that one, then we have these two resistors for the USB port and C1. So let's highlight those. So we have these parts. And we should place them close here to the USB interface somehow. And then we have the two last resistors here and a capacitor. That's a capacitor and resistor. And that's R8 and C7. And let's see where they are. So these are the ones for the user switch. And we just move them around here. Like that. So now we have the parts approximately where it makes sense to have them. And I think we could try and view the board in the 3D viewer just to see how it looks. This is one of the very cool features of KiCad, I think. It's just awesome. We already have a very good idea about how the final design would look like. We need to look at some of the labels around and move them around and just move the parts a bit so it makes sense where they are according to where we route the pins. And I think we will start routing, the most important things on the board, and that's That's USB lines here going from USB connector through the transient protection and up to the MCU. So we will need to make some rules for that. But I also see that we are missing a few 3D models. One for the RGB LED, one for the sensor, the quick connector up there. So I can just show you how to put these 3D models in if they are not already defined. Okay, let's close the 3D viewer for now. And let's have a look here on the sensor. And I think I have downloaded some of these 3D models before. I have the SI7021. And we need to rotate that a bit. Like that. And I think it looks to be placed correctly. Let me just say OK to that. Then we have the RGB LED. Let's add a model for that one. I believe this is this one. Perfect. Then we have the quick connector up here. Let's see if we can find that one. I think this is one. Yeah, and we just need to move that one in place. Like that. Is the height okay? No, it's a bit too high. .2. Yeah, maybe should be 2.5. .30 maybe. Sorry. Double click. Yeah, I think that's fine. And then we just need to move it in place. I think something happened to it. There's a problem there. Like that. Yeah, maybe should be in a bit more. 2.5. Maybe 30. I think that's good. And let's check up on all the models if we have everything in place. Just save now. Let's say view 3D viewer. And I think that we have all 3D models loaded now. Perfect. And let's take, I don't want to have these labels or reference designators here on the mounting holes. So let's get rid of them, like that. And now I think we should focus here on the USB interface, and let's start to maneuver around in this area. So what we want is to have a differential pair here from the data lines D+ and D-, going up to the transient protection here. Oh, sorry, I want to move U1. Maybe something like that. And then we can route a differential pair. You just say route and then route the differential pair. And then you can route them down here to where they match. There's some rules we have to set up in order to make it with the correct impedance. But I think that the placement looks fine here. And let's check it out. There's a tool where you can calculate the specifications of how you do the tracks, and it depends on a few parameters. So we are going to route this on a 4-layer board, and this is PCB way that are going to produce this board. So we can just check up on the parameters that they have for a 4-layer board. And what's important here is to look at the distance between layer 1 and layer 2. And you can see for most of their 4-layer boards, they have a pre-peg of 0.1960 millimeters. So there's approximately 2 millimeters or 0.2 millimeters between layer 1 and layer 2. So that's one of the parameters that we need to calculate how we route the tracks. And I normally use this tool here. And I also provided the link in the description so that you can also download this tool and make calculations on your tracks to find the correct the impedance. So what I selected over here, that I have a USB 2 differential protocol, and I would like to have like 90 ohm of resistance, that's or impedance on the USB tracks, and then I need to adjust the conductor width and the spacing in between the two signals. You can see how to place them down here. So one of the parameters is the height between layer 1 and layer 2, and that was 0.1960 millimeters. So that's what I entered here. And normally a manufacturer, they can do conductor spacing with 0.15 millimeters. So that's what I just used here. And then accordingly to the resistance down there, or the impedance, then I can calculate the width of my conductors. And you can see here, if I change that value 0.2, then the resistance down here will change. So I found that 0.24 millimeters is fine. Then I will have an impedance of approximately 90 ohms, and that's well in between what's needed. This is 89.6. That's it cannot be done that precise anyway. So if I use a conductor width of 0.24 millimeters and a conductor spacing of 15 millimeters, then it should be fine. And then of course I need to buy the correct PCB with the right specifications here. So now we have the data, and then we can enter that into KiCad. There's a specific place where we have to insert these rules, or we will make a class in here for the tracks. And I can just show you how to do that. So we go to File and then to Board Setup. And we should of course also say that it's a 4-layer board. So we just specify that it's a 4-layer board. And the specifications that we have is that the prepeg was 0.196 millimeters. And the core is 1.03 millimeters and 1.96 millimeters. And then you can see here this gives a total board thickness of approximately 1.6 millimeters. So alright with that. And then we have here the design rules, and down here we have some net classes, and there's a default net class here that says okay, the clearance should normally be 0.2 millimeters and track width 0.2 millimeters and the via size and so on. And I think these are fine, but we will make another class and call that one USB diff. And normally you would have like 3 times the width of a track, and that was 0.22 millimeters or 0.24 millimeters. So we can just say like, for me it's good with 0.6 millimeters. And the track width was 0. We can just say that's 0.2. It doesn't matter because we have to change it for the differential pair here. And the width was 1.15, and the width was 0.24 here, and the gap between the tracks was 0.15, like that. And then we need to assign it to some different nets, and then we just say plus here, and we need to insert the name here of the track, and you can see if we push the star, then we get all the nets that we have. And you know, there's this D plus net, so we can just write /D plus, and we can add one more, and that was /D minus. And we can add one more and say star, but then we can find the names of the other nets that we have on the other side of the protection device, and this is called USB D plus. And then hopefully we can insert that here. And there we have it. And then we need to do the same for the minus. We need this slash in front here. And there we have the D minus. And now we have assigned these rules to the tracks here. So when we route them, then the length of the tracks will be 0.24 millimeters. Let's see if that's the case. And then we say route differential pair. And then we connect them down here. And let's have a look on the specifications for these. There's a problem that it didn't take the right value, so we have to check it up again. And let's see for board setup. And we have the And we of course need to put it to the correct net class. That was what I forgot. Say okay. And then we can just try and unroute this stuff again. Just delete the tracks. Like that, and then let's try again. Place, route, differential pair. That's funny. Let's try here on the other side. Maybe there's a bug in the program. Route, differential pair. Yeah, there seems to be something wrong. It cannot. And you also saw that the window made a small, it didn't update that well. So let's just try and save it, file, and then close it, and then open it again. Like that. Let's see if that corrected it. Route, differential pair. Apparently this is not the issue. Maybe there's something wrong with the rules that I made, so it's not possible for it to route. So let's check up on the rules again. And then let's have a look here. We can try and move the clearance down just to see if it has something to do with it. And I think the values looks fine. Let's see if it was something with the clearance. Route, differential pair. Okay, there's something with the clearance. So let's try and route it again here. And now you see that it has the correct width, and we also have the correct distance here in between. And now we can just route it manually, the last distance, and then we can take the other pair here, route differential pairs, and let's try and move around. Route differential pair. There we have a problem. So you can see these are crossed. So I think we have to do something. We have to change the way that they are routed through here. So we have to go back to the schematic and and change something, because we cannot make them go cross each other. So we can just delete the tracks here. Like that. So now they're gone. And away with that one. And those two. So we have to change the polarity here. So we have to go back to the schematic. And we need to change the way that they flow through here. So we need to say this is D minus and D plus. We have to change those two. That. And like that. And we can just verify that we have D minus going to D minus here, and D plus to D plus. And D minus and D plus. That's fine. Let's save that. And then we can say tools, update PCB from schematic. And then we update, and we can see something happened to the D plus and D minus lines. And we can see something changed down here. And if we try to route the differential pair up to the MCU, we should then see that it's correct now. So route differential pair. And let's see if it is correct this time. Yeah, this looks better. Like that. And we can just verify that we have 0.15 millimeters in between here. So let's go and have a smaller dimension, and then we can say inspect, measure tool. And we have 0.15 millimeters here as specified. And we can just go back to 0.1 millimeters. Okay, yeah, sorry for that. That's sometimes when you do stuff, then you have to correct things afterwards. But we have to take care of the USB signals here. And route differential pair, then we can route down to D plus and D minus here. And you see that they are now crossed here. But it's not a problem because they are, on both sides here. So we need to go to, this is the D minus line, and this is D plus line, so we can take that pair over here. So we can just say, delete that again. And then we can try and go from bottom up. Route differential pair, and then we will take this and the closest one there, and then now they should be happy, like that. So I think we should make room for a via down here. I think we need to have like 5 volt coming in, and then we need to have something with a ground. So maybe we need to move these tracks a bit. Still, we need, because we need a via here. Or maybe it would be prettier if I did a via first. Let's see, what can we do? I think I'll need to remove this again. Like that. Like that. And then I need to put the VA in first. Like that. Because I need this to be connected to ground. And I need to get 5 volt out of here. Like that. And then into the decoupling capacitor here. Need to move these 2 resistors. This might be easier to move that one first. Move them over here. And then move this one closer here. Like this. And I can just make the grid a bit finer. Something like this. And then just try and route this out. Like that. And then go to a via. And then here we will have the ground via. Just delete that one. And then Shift Control X. Then we have ground via. And then we can try and route the rest of the differential pair again. And we have the minus side was there, so we have to go on minus first. And sometimes you have to manually route the last bits of the tracks. I didn't seem to hit the middle that well. So I can just delete those and then say route differential pair. It's a bit fiddly, this stuff. I need to go back a few steps, I think. I can press U, then select all, then highlight it, and then delete. Route differential pair. And then it's over here. So I have to hit the middle here. Approximately there. and then I need to route it manually. I'm not so satisfied with this. Maybe I can go from the other end here. And then hit the others. Like that. Alright, that took quite some time, but it can be a bit fiddly playing around with this, the differential tracks, and get them routed. But now they are as they should be. And that's the most important tracks to be routed. And then we can just continue routing the remaining tracks. And we have this 4-layer board, so we have the signals on the top layer and the bottom layer, and then we have ground on the second layer, and the third layer will be 3.3 volts. So let's route the power supply for the MCU or the ESP32. Just move around with the parts here a bit. Like that. And then we can move the designator here down here somewhere. And then route, press X, go down a bit more with this one. Like that. And then to a via here. Like that. And I want these tracks to be 0.5 millimeters, something like that. And we'll place a ground via here, and also a ground via there. And then we can move the label down a bit. Like that. So we can check up on the I2C pins. So we have SDA and SCL here. And we can put the designators here on the top. Like that. And we should rotate it. Like that, and we can move the designator as well for this one. Move down a bit like that. Let's connect those to 3.3 volts through a via. Like that, and then we can route the SDA line. And the SCL line. Like that. And the 3.3 volt, we can just place a VA in here. And we can do the same for the ground. But that will also automatically be connected to ground when we do the copper pour. But for now, we just place a VA close to the pad. That was the I2C, we can just connect the pins to the relevant pins on the MCU. And we could just place or we could just go around. Let's place a via here. And then go to the opposite layer, the bottom layer. And then route it over here. Place a via. Connect it. And we have the SCL line is coming down here from pin 17. And we'll place a via here. Go over to the other side. And a via there. Like that. And I'll just move this up a bit. Like that. And move the via a bit. Like that. That was the I2C interface. And here we have the pull-up resistor for GPU 3. And let's put a via on that one. Like that. And we need to go inside, so we need to go on the opposite side here. Place a via. And we need to go down here. And we have to stay a bit away from the USB lines. And the via there. And then route the track there. Sorry. It'll be like this. And just move it so it looks nice. Like that. Then we can take all the pins for the SPI port. And we could just put some labels on. And we just place some text then, place text, and that is 3.3 volts, and that should be on the silk screen layer. And maybe this is a bit too big. I want it to be 1, and 0.2 maybe. Let's check it out. One and 0.2. Yeah, that's more like it. Could maybe also make it even a bit thinner. Like so. Put a bit in. Like that. And we have the same on the other side. And there we have the resets. Moshi. And Miso. And finally the ground. GND. And we can move that on the other side as well. Then we have the interrupt. And we have the clock. And then we have the chip select. Like that. And then we can just find the outer limits here. This is approximately there. And for the top, I think that's probably there. Then we can select all the 5 labels. And then we can say align distribute. And we want it to be equally spaced by centers. And we need to have it aligned, centered, like that. And if it just touches the margin there, then that looks okay. And let's do the same for the other side. And move the ground label. It's approximately the middle there. Then we select the 5 labels or texts. And we align like that. And align like that. And then we can move it out in the right position. So just so the plus touches the margin there. Something like that. And they are close to be. This needs to go down a bit. Yeah, that's perfect. Alright, and we could also just put a small label on here to say that this is a quick connector. Like so. This area seems to be fine. Then we can just move these parts for the power supply. This is a 5 volt. Coming in. Let's have the fuse here. Then we can take the diode, move that down here. And we can take the inductor and place it like that. And let's take the labels or designators and move them. And the fuse. Something like that. And the diode, we can just move it up a bit. Does it turn the right way? Yes. Like that. And we can also maybe move the LDO a bit. Oh. move. Like that. Here we have the power LED. We can just route the tracks for that one. Like that. And then we can place a via here for the 3.3 volts. And just a via for the ground. And now we can route the power going into the fuse, going into the ferrite bed, going down to the diode, and then feed it into the decoupling capacitor. Can maybe move this up a bit, like that, and then we can center this with the LDO. Like that. Like that. And then we can move this one a bit back. Like that. And then we can wire things together. And then we can have the power going into the net of the plane, the 3.3 volt plane here. And we can connect also pin 2 up here. And we just need the tracks to be a bit wider. Be 0.6 millimeters maybe here. And let's see this one. I think that will go for 0.5 millimeters. Yeah. Yeah, it could also be 0.6 this one. So just select one track, press U. Properties 0.6. Perfect. And we also need to connect the other side. There's also plus 5 volt over here, or the V bus is in here. So if we place a via here in the middle, and then we place a track on the other side. Place a via here. And connect this. Like that. And then for the ground pins we can place a via close here. Like that. And then we have the 2 resistors that we need to connect. So we need to get them over here. Have them close by. That. And CC2 is the first one, yeah. Let's see what we can do here. Try and move the designators. Like that. Then we have the ground connected. So CC2, we can take that without any problems here. And I think CC1 we need to get the other side here. Like that. That was it for the USB interface, I think. Then we could take the LED. It's very easy with these resistors. And then we can try and move them up through the system, but maybe we should take the parts that are a bit closer by. Let's first take the sensor here. And route the power supply for it. And place a via for the 3.3 volt. And one for the ground. Like that. And also one for the ground over here. And then the SDA line. Can just move it to the opposite side. And then try and route it like that. We can just make this, move this a bit. That was the SDA line and the SCL line. I think I need to go behind it because we need to route all the pins for the SPI port. I would like to go to the other layer here. And then to the bottom layer. Maybe we can catch it here. Like that. And I think I need to move stuff away from here. like that. Alright, so let's have a look on all the SPI signals. Like that. The clock. We just center that a bit like that. Miso. And then we have reset. And we can see that's on the other side. So let's just go here. And then switch to the other layer. And then reset is also connected. So to get rid of some of these lines, we can also put on the copper definitions or the copper layers, what kind of signals we want to have on the different layers. So we can just place a filled zone. And let's select the 0.1 millimeter grid. And then we know, okay, the top layer and the inner one layer and the bottom layer, they should have ground on them. And we say that we should have 0.2 millimeters of clearance, minimum with 2 millimeters. Yeah, just 0.2 millimeters of these parameters. And it's a solid fill, and we have it for these layers. Okay. Then we have just to select 0.2 here. And then we just draw all around the board. Just double click here. Then there's a copper pour on all these three defined layers. And if you press B, then it will make a fill. And then you see it can be a bit difficult to see because we have three layers that are completely filled with copper. Then we can go to objects here and say zones. And then we can move up and down, you know, the opacity here. This is fine, I think. And then we can see the ground vias, they have been connected to that layer or these layers. And then let's define one for the 3.3 volt net. I'll place fill zone, and we place the starting point here. And we'll have a 3.3 volt net, and we will have that on the inner 2 layer. And we just say the same. like that. Okay. And then we go and place a square here. And double click. And we can press B. And then it made the power layer. Or did it? We can just verify it by switching off the other layers. Yeah, we can see that there are a layer in here, so we just need to put up the opacity here, and then we can see it a bit more clear. And we can also see it here on the connectors that they have been connected to that layer as well. Perfect. And we also, we can notice that some of the lines that were over here, they are gone now. There are just some details here with the 5V net we need to take care of. But let's take down the opacity a bit. And let's see. We need to turn on the other layers again. Like that. And maybe we have to turn it down a notch. Like that. And we could just verify that we need to have the 5V up here connected to 5V down here. So let's draw a wire. And we need to go into 0.1 millimeter grid. And let's place a via here. And switch to the other layer. Like that. I think that we also would like to have that a bit thicker. 0.5 millimeters. Like that. Alright, so let's route now the programming header up here. So we have the enable signal and the UART lines, so maybe we can have these in the top layer. Like that. And of course that's not possible, but we just place a via here. And go to the bottom layer. Like that. And then we have the enable signal or the reset line. And we place a via here. Go on the other side. Like that. And then we have the boot line here. So we need to connect that pad. Let's try and route it in the top layer. Like that. And then we have the enable should go down to the circuitry down here. there for now. And then we need to move this around a bit. Just take the capacitor and place it a bit outside here. Like that. We can try and route the tracks first. Maybe we should make the grid a bit smaller again. Like that. Like that. Then we have the resistor, the pull-up resistor. And connect it to 3.3 volt. And there we have the signal coming here. And we can just place a via here close to the resistor. Like that. Then we have the boot switch. See how far we can get with this one. Something like that. And here we have the user switch. We can try and route this pin here. And this should be ground. And did we have a via here? No. And we can also place one here close by. And one here. Let's try and finish this one up here. And let's place a via there. And where do we have that pin going to? That signal. Okay, we have it right there. And to the other side. Via there. Like that. Like that. And now we are missing the LEDs here. Let's try and see if we can find a route down there. I think we need to go to the backside. Like that. And it's of course a bit of a problem that this one is there, but I think we can manage. Just go down here, straight down to this part. And the next one. That, and the last LED. Just place a via here and then move the designator afterwards. Like that. And then we can say move the designator over here. And the other one we can move down below here. Like that, then there's no via in the middle of the designator. And we need 3.3 volts. Just need a via here. And then that line also disappeared. This is okay. This is okay. Like that. Just need to reroute that. Could just take this one away like that. Remove that mirror. Like that. I think that's finally all the tracks so far. Just have to check up on some of the designators that they are okay, that their location is fine. I think there's an issue here. G1 here. Something like that. We could also move all this stuff up a bit. No, let's not do that. I would like that to be inside here. This was 0.6 millimeters. 0.5 it was. Sorry. 0.5. And save. So we could just have a look on our 3D viewer, just to get an impression of how it looks so far. And if there are some of the designators that needs to be moved or something we need to add, I think that's fine. So we can just add a few labels to the board. So down here we can write some information about the board. So this is version 1.0, ESP32-S3 Testboard. And it should of course be in the silk screen. And did I, yeah, that's, I don't know why that is flipped. That's strange. Let's just flip it. And then it should be silk screen. Okay. Can we move that? And maybe it should be a bit smaller. One, two, 5. Like that. And we could also put that on the back side, duplicate it and flip it. So we also have the text on the bottom side. And I could just insert a logo here. I think I have a YouTube logo somewhere. So maybe there's room here. I can just remove the designator. Like that. Just a bit of commercial. place text. And that should also be on the silk screen. It's because I'm on the bottom layer that it flips around all the time. So that should be silk screen. And we can move C4 down a bit here. Let's check that out. And we can also maybe make a small label here with the sensor. Like that. And we have reset and boot and switch 3. I think we are getting close here on the top side. You can also have a look on the bottom side. So we say view, and then you can go in flipboard view, and then we are on the bottom side. And I would like to have a KiCad logo as well. Place footprints. And let's see, we have it in symbols. And KiCad logo 2. Something like this. Maybe it's a big too much. Maybe it should be the 12mm. Place footprint. And that one. Yep. So we can put it here in the middle. Something like that, and then we can make another text. Draw texts. Then powered by and of course the sponsor PCB way. And we want that in the bottom silk layer. And we can place it up here somewhere. Like that. And let's check it out in the 3D viewer. back to normal again. And there we have it. And you can see here I just need to remove this, and it's just an update of the copper layer, and we can just do that easily, and that's just by pressing B. And one final thing I would like to do is to place a few more vias. There's also like a track here that is not connected. Let's see, what is that? Oh, that's the interrupt pin. So we need to route that as well. And I think we can just route it on the bottom layer here. So let's move the grid bit down. That bottom layer. And then a via here. Like that. I wanted just to place a few ground vias, so we can just take that one, and I would like to have that on a 1mm grid at least. And here close by the antenna. Something like that. Like that. And we can also just pour a few around the board, just to tie the nets together. And we don't need to be on that grid anymore. Duplicate. I think that's fine for now. That's it. And we can just try and turn on the zones again. Then it's, see here we are on the back side. There's something missing, a bit of copper here. So maybe we can put We need to do it here with the zones. And we can try and put some more ground in order to fill it. And then you see the ground has been filled. And let's see if we can make a design rule check. And let's see if there's some errors pops up that we need to take action on. And you see there are some problems here on the edges. That's fine. And some places where the silk screen has been clipped. And this is an error of the hole size here, that they are too small. They need to be changed. But my manufacturer, they are able to make them with 0.2 millimeters without extra costs, so this is also fine for me. So no serious things, but we can see here that we have 2 unconnected items. So we just need to take care of those and see what it is. And this has not been completely routed. Just press finish. And finish. Oh, flip, that's wrong. Like that. Okay, the design is done. We are ready to ship off the design to our manufacturer, and the way to do that is to go and generate the Gerber data. And if we go to fabrication outputs and Gerbers, and then we say plot, we have all the selected layers here, the 4 copper layers, the pasta, silk screen, and the mask, and the edge. And we just say plot. And then you have your data there have been generated. There was a warning. There has been a very, very thin wire somewhere that has been corrected. And we can generate the drill files. And we have the drill files, and then we can go and upload the data directly to PCBWay, for example. So I installed the plugin. So if we go to Tools, External Plugins, and then to PCBWay, then it will take all the data that you have and compile it and zip the files and send them directly to PCBWay. And then we can just say this is the top layer, and this was the inner 1 layer, the inner 2 layer, and the bottom layer. And here we go. The data has been uploaded 50 by 50 millimeters. And now you can select how many you want and what kind of surface treatment and colors you would like to have. So let's have a look on the 3D view one more time. And enjoy the hard work. And now we are ready to order the PCB and try out some prototypes with the Espressif ESP32-S3. So I hope you enjoyed the video and you learned something. See you in the next one. Bye.